Hello everyone. In the next few minutes, I will give a very brief overview of R. R is a statistical tool that is mainly used for data analysis and visualization. It has software packages supporting not only statistical functions but also functions for data analysis, plotting graphs, etc. R also supports writing programs. That means you can implement your own functions in R. But please be cautious that programs written in R can be extremely slow. However, for some domain specialists, R might be a very user-friendly environment to work in. Before you can use R, you would need to download and install it. Please follow the link on this slide to download and install R on your laptop. Now I will provide a short demo of using R. I will be using the R installation on the compute node of the Stampede supercomputer at TAC. The first two commands that are shown in red color on the slide help in providing interactive access to a compute node and in setting the correct paths for accessing R on Stampede. To begin working with R, type R at the command prompt. If the path to R directories are set appropriately, then this command will result in starting the R environment and will present a prompt which is shown in blue color on the slide. You can now run the R commands on this prompt. To quit the R environment, you may type Q followed with round brackets. R operates on named data structures. The simplest such structure is the numeric vector, which consists of an ordered collection of numbers. The inbuilt function in R, named C, can be used to create such vectors. The function C can take an arbitrary number of vector arguments, and it can return a vector by concatenating its arguments end to end. For example, to set up a vector named myVector that consists of 5 numbers, namely 1, 2, 3, 4, 5, you may use the R command myVector equal to C round brackets open 1, 2, 3, 4, 5 and round brackets closed. Now that you have a vector created using this aforementioned command, you may perform statistical analysis on it using other inbuilt functions in R. For example, to find the sum of the numbers in the vector named myVector, you may use the function sum and pass myVector as an argument to it. Likewise, you may find the mean and range of values stored in the vector. You may also find the maximum and the minimum values stored in the vector by using inbuilt R functions. Let us now look at an example of plotting graphs using R. We will create two vectors for this example. A vector named myVector having values 1, 2, 3, 4, and 5. And another vector named scores with values 10, 3, 7, 10, and 1. In order to plot a graph such that the values in the vector named myVector are on the x-axis and the values in the scores vector are on the y-axis, we will use the inbuilt function named plot as shown on the slide. By following the link on the slide, you can learn more about the plot function in R. You may also use R as a calculator. So once you have the R environment started, then at the command prompt, if you type 1 plus 2, you will get the result 3 in the following line. And if you type, let's say, 2 minus 1, you will get the result 1 on the following line, and so forth. We have already seen one way of creating vectors in R, and that is by using the inbuilt function C. There is another inbuilt function named seq or seek that can be used for creating vectors, and the example on the slide shows how to use the seq or sequence function. In addition to creating vectors, you can create strings, numeric or logical variables in R, and you would use the assignment operator or equal to sign for assigning values to the variables. Now let us look at some examples of operations on vectors. So for example, if you need to look at the values stored in a vector, all you need to do is type the vector name on the command prompt and then press the enter key. Once you've done that, the contents of the vector will be displayed on the following line. Now, if you need to increment each value of the vector element by 2, then all you need to do is type the vector name plus the number 2 and press enter. That will increment each element in the vector by 2. You could do several other operations like sorting the elements of the vector, raising the numbers in the vector to the power of 2, and so forth. Now let us look at an example of creating and using matrices in R. A two-dimensional matrix in R or in any other programming language can be thought of as a vector of a vector. So let's assume that we have a vector named vec1 and a vector named vec2. These two vectors, vec1 and vec2, can be combined to create a matrix M1 by using the inbuilt function named cbind in R. The example on the slide shows you the exact syntax of using the cbind function. Now, after you have run the command for creating the matrix M1 as shown on the slide, you can just type M1 on the command prompt and press enter, and you will see the contents of this matrix. Now, if you want to transpose the matrix, you can use the function named T for transpose. So the function T takes an argument, which is the matrix name. So if you had created the matrix named M1, you can pass that to the function T as shown on the slide. And what this will do is it will transpose the matrix, that is, turn the columns into rows and rows into columns. Now that was a very, very brief overview of R. Think of it just as a trailer of what all is possible if you would use R. Now, in order to explore R further, I recommend following the references on the slides. And if you have any questions, please feel free to contact me. Thank you.